Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
Hello, Dylan here. On today's episode, we are revisiting the topic of our very first Buildings and Beyond episode, Passive House. It's been 6 years since our inaugural episode that featured Lois, the director of the Passive House group here at SWA. In that episode, we discussed the top 10 most frequently asked questions about Passive House. Fast forward to now, we are revisiting the FAQs that were originally discussed that are still being asked today. Is the answer the same as it was 6 years ago? Or have things changed over the last 6 years? We also discussed new FAQs that weren't discussed in our inaugural episode. Topics covered in this episode include cost premiums for Passive House, windows, ventilation design, code conflicts, and other pressing issues that our Passive House team is regularly asked. Now, before we begin, I'd like to encourage you all to check out the Passive House Accelerator. This is an online community and media company dedicated to accelerating the transition to clean, resilient, zero-carbon buildings. Among many things, the Passive House Accelerator hosts live online educational gatherings, puts out YouTube videos regularly, publishes a magazine twice a year, hosts the Reimagine Building Conference series, and even has their own podcast. To learn more, please visit passivehouseaccelerator.com. Now, this episode begins with our host, Rob, asking Lois and myself, also in SWA's Passive House group, what FAQs have essentially the same response to what was discussed 6 years ago.
We'll start with some of the same questions we talked about 6-ish years ago that have the same answers, but that still deserve attention. We're still getting the questions, and it makes sense not to gloss over these questions. And those questions are, number one, is there a price premium? Lois, is there a price premium to Passive House?
It depends on who you ask.
I am asking you. Thought that was pretty straightforward.
Yes, there is. If you have a building in mind, you've set it up, you know the basic shape, you know the basic mechanicals of it, you're building it to code. If you're going to Passive House from there's a price premium generally in the windows, and there's a price premium in the ventilation system. But those are the two biggest premiums. And It generally comes out for our affordable housing projects that are larger than 50,000 square feet. You got to, as a percentage of a building's budget, it's probably somewhere between 3 and 5% premium.
Okay, so starting with building already in mind, not designing with Passive House in mind necessarily, but just going to Passive House.
Exactly. If you start it with Passive House in mind, with just program, I need this many apartments, I need this kind of community space, give me a Passive House building. We've seen it between 0 and 2%.
Okay. That's pretty, well, yeah. If you look at overall project budgets, 0 to 5%, 0 is obviously not a lot. 5% of overall project budget is not anything to sneeze at, but it's still feasible. Seems like a reasonable and feasible premium.
Absolutely.
Okay.
Yeah. I would also add that I think the baseline is harder, more confusing to figure out because of codes and how they're getting more progressive. So like in Massachusetts, Passive House multifamilies almost pretty much required now. So, what's the price premium to something that's required? So it's very locational specific. And, that's always been, I think, part of that discussion is what's the baseline? But now, even more so than 5 years ago, I think it's more tricky in terms of what the baseline is.
Yeah. If it's required by programs or statute, it's just the question is moot, I guess.
Right.
Yeah.
Good point. Second revisited question. Are there restrictions to glazing area? Dylan.
So there are no hard restrictions in terms of you can't exceed a certain window to wall ratio or anything like that. They don't exist. However, the passive house design has to comply with the performance requirements that are prescribed by the standard, and you have to have an energy model show that your building meets those performance requirements. So the specific ones that really are impacted by windows are the heating demand and heating load, cooling demand and cooling load. And if you have more windows, and windows are worse than walls per se in terms of the overall insulative value, the insulation that those windows provide, then you could say that the windows will hurt you. However, it's a performance-based standard. So if you want more windows in your project, then you have to make up for that with maybe a better wall or a better energy recovery ventilator, something that's more efficient in a different area of the building. That's one of the hallmarks of passive houses. It's a performance-based standard. There's flexibility. But one point that I think is worth noting too is that with a passive house building, especially in the Northeast climate, which is what we work in mostly, you're often looking at either the best double pane window you can get, or in most cases, triple pane windows, especially the further north you get. And a triple pane window, is roughly an R8 when you look at the R value of it, as compared to a more conventional code minimum type window right now, which is more of like an R2 or an R3. That added implication of having windows is actually less impactful because you have such a better window. So when you have a really good window, in my opinion, you can actually get away with more windows because you have a better window. So what we found is that passive house has actually helped, particularly market rate projects, sort of justify higher window to wall ratios because the windows are just better. Now you can always overdo anything, so you have to use it within reason, but there is no restriction on window to wall ratio or the amount of glazing area. It just needs to there needs to be thoughtful design, and it needs to be considered when running the energy model to show that you're complying with the passive house criteria. That's the biggest thing.
And that goes back to the first question about cost. Lois, you mentioned windows are one of the big drivers of cost.
Exactly. That's kind of where our teams restrict, right? So they get the pricing on their big, huge windows that they love. Compared to the wall, it's a lot more expensive.
Yes.
So if you want
Right.
to, bring your costs down, that's a good place to be.
Okay.
Yeah.
Gotcha. Now, one of the other things I remember talking about 6 years ago is that, yes, good windows are necessary in a lot of buildings, triple pane windows, good triple pane windows. They were hard to get 6 years ago. Has that changed?
Extremely.
Okay.
Extremely. We tried, for a while, we were keeping a list, a catalog for our builders so that we could give them things and contact names and people to call to get the windows we were specifying.
Okay.
We can't keep track of it anymore.
Oh, there's too many.
There's too many.
Oh, that's a great problem to have.
It's a
All
good
right.
problem.
Yep.
Nice.
Yeah.
Excellent. All right, the last one of the revisited questions with the same answer. What is the change to the construction schedule for passive houses? Lois.
We put this down here again because we keep getting asked it, especially as codes adopted and more builders are forced to do it. The answer is no change to your construction schedule. Don't let your contractor add in schedule delays because you have to do passive house. That is not the case. The passive house team will work with your schedule and around your schedule to do all the inspections and testing we need to do. We will not slow you down.
All right. Anything to add?
No, it's a common question, and you're absolutely right. We need a day to do a whole building blower door test, and that gets coordinated probably 3 years before the test. So if we don't have enough time to figure out what's going on that one day, then we have some serious problems.
Gotcha.
Very good point.
Cool. All right. We have another few questions that are the same questions, the same FAQs as the last time we chatted, but with different answers, or at least modified answers. Do passive houses require increased O&M? Dylan.
So this is a great question. I think when we talked about this, I wasn't on the first episode, but when we talked about this previously,
You're recording. You're sitting behind the
true.
board, recording.
Yeah, that's true. I was
listening and recording.
I was behind the curtains.
Pause.
Yeah. So I believe we said it. It's really not expected. In theory, it should help lower operating costs because of the energy savings potential with the passive house design. What we're finding now, I think, though, is that maintenance costs on the systems in the building, particularly the ventilation systems, is where we're seeing from projects that are now in operation for a couple of years, particularly multifamily, where we have a lot of projects now, a good base of projects in operation for over a year now. The maintenance costs in the ERVs, the energy recovery ventilators, are one that I think is more than what we anticipated. There's been issues with the energy recovery ventilators not working properly in certain instances, fixing those issues. Ongoing commissioning of these units to ensure that they're working properly is something that we're finding is a need. And I think this, for one, is probably related to the fact that a lot of these systems, like an energy recovery ventilator, are not common for people and building operators that are used to more code conventional buildings. So in many ways, there's a lot of newer stuff in these buildings, and there's a bit of a learning curve on how to properly maintain them. So example of that is filters on ERVs, the energy recovery ventilators, really should be changed at a minimum no less than 2 times a year. And if those are not changed at that frequency, at that rate, you can run into issues with the fans getting burnt out. You can run into other sorts of mechanical issues. You're also not potentially getting the air in the building that you need, or your fans have to work a lot harder to get that air in because there's much more pressure because of filters not being changed and getting clogged. So there's a lot of issues associated with, particularly on the ventilation side, that we're finding more O&M costs than I think we anticipated 5+ years ago. So we're actively working on, a strategy to address that with these building operators.
God, yeah. In my experience, building maintenance folks, the turnover might be 9 months on average. So if somebody learns everything that's needed to maintain these systems, they change a filter once, and then somebody else has to learn what's needed.
Yeah.
Lois, any?
We had an interesting comment from one of our early on passive house, large scale multifamily developers that said they actually pay more for their building operators because they actively recruit from hotels, the hospitality industry, because they're used to this type of equipment more than a multifamily building.
Oh,
they're used to VRF. They're used to the heat pump technology, right? We see that. We've been seeing that in hotels for years. So they're paying more just for the building operator, not necessarily for extra maintenance or anything like that. Yeah. So I thought that was an interesting concept,
Yeah.
Yeah.
It's a challenge. Yeah. That's interesting. Paying more for the people.
Yeah.
Not necessarily for the equipment itself.
Yeah.
It makes sense. It really just ERVs. ERVs is the only thing that you've mentioned. Is that certainly the top of the list?
ERVs is probably the biggest one. I think the other one that we've seen is some of the heat pump systems, particularly VRF, variable refrigerant flow systems. That's a very new technology in terms of the grand scheme of things for heating systems and cooling systems in buildings. And those things are very complicated in terms of how they work, especially ones where they have the ability to heat and cool simultaneously, per condenser. So we found that as well, I'd say, to be another aspect of these sort of new systems that require particularly careful attention to operating it properly. And if that's not done, then maintenance costs can certainly be higher as a result of that.
Gotcha.
So that's it on the system side. I would also add that, one thing that's tricky with the discussion of operating costs is how the costs of fuel in general and the costs of electricity have gone up significantly, even in the last few years. So, one thing that we're finding is that building owners maybe are looking at the utility bills and going, I'm paying more for energy than I was a few years ago. And
In a passive house, you mean, or in just any old
generally
building?
speaking.
Okay.
I mean, yeah, we've certainly in certain cases, we've heard, hey, these energy costs are a bit higher than we expected on this building, or we compare this. We have comps of other buildings that maybe are not passive house that we've had utility bills from years ago. We're used to paying a certain amount for energy in those buildings, and it's more than that, and so much of that is just due to the fact that the cost of electricity has gone up significantly in the past 3 years alone, I would say. And
they typically were heating with gas.
And they typically were heating with gas too. So you're right. So you're moving away from a subsidized fossil fuel industry where the cost of fuel itself is just lower relative to electricity, and you have essentially the switching of where the cost is going in terms of the fuel type and electricity for heating systems now. So that's certainly something that we don't want to sweep under the rug. It's a factor, but when talking about is our building more efficient than other buildings, you have to look at this on an energy use basis, and then as far as energy cost goes, being aware of how rates are impacting that is really critical to that discussion. So yeah, it's very easy to get confused with those those aspects we found.
Yeah, absolutely. Okay, next question. Do passive houses require changes to standard practice? Lois.
It depends on the building construction method. So for most of our large-scale projects in the city that are non-combustible material, CMU backup wall, steel stud, not really. It's just more of an attention to detail.
And that's why I think 6 years ago, you basically said no. It's attention to detail,
Correct.
but no big changes
No big
to
changes.
standard practice.
Exactly.
Yeah.
However, since then, we've worked on a lot more wood frame construction projects. And there lies the problem.
A problem, a challenge.
A challenge.
A change in standard practice.
Three-story multifamily building can be exponentially harder to air seal than a concrete flat roof ceiling.
Okay.
Right. So there's been some changes to standard practice now. When we talk about wood buildings, we typically see zip sheathing on those wood buildings, and zip is sold as an air barrier product. And if you did what you were supposed to do with zip, I could also say, no, there's not really much of a change to standard practice, but standard practice is not what the manufacturer recommends.
Okay.
So yes, with wood frame construction. And there's also a change in the standard practice of how the roof connects to the walls.
So let's now, before moving on from zip, what is the big, is it the seams, taping the seams? Is it the other connections to windows?
All connections.
Okay.
It's the seams, it's the penetrations with the nails, it's the connection to the foundation. They all require different type of seal and attention, and you have to just be meticulous.
Okay.
So, yeah, that's what it is with zip. Now, their guidance on how to do it is spot on.
It's solid.
Yeah,
Okay.
Rollers, primers, right?
That's
Like
as an example,
there.
the roller issue is one thing that I know our construction team, the folks from our team that are out in the field on a day-to-day basis are constantly getting on the builders is use a roller.
So this is on the tape, taping
This
the
is for
seams.
tape,
Yeah.
exactly.
Yeah.
So for air sealing tape, if you just kind of try to push the tape on and have it adhere to the backup surface alone with just hands or whatever method you want to use, that's not how the manufacturer even says you should apply it. They say you should use a roller to apply adequate even pressure, and this prevents things like fish mouthing, things that will essentially exacerbate the air leakage issues. So.
Okay, so zip is one big change. If you're trying to get your air barrier with zip, that's a challenge. You had started to say something else about wood frame, Lois, near the roofs, near
Correct, where the truss meets the wall.
Okay.
It's a notoriously difficult detail to get right. There's more than one way to do it, so I don't want to go into it on the air. Picture's worth 1,000 words, but it's really difficult, and that requires a change of practice.
Okay.
Yeah.
All right. So you got to catch that in the details during the design. Okay.
Yep.
Cool.
And to that point, I think too, it's when you have a contractor involved in the design phase of the project, it helps alleviate these problems so much. So, I think 5 years ago we said this and believed it then. we say it and even more now and believe it even more now because we've had projects that do that or don't do that. And there's a big difference in terms of the ones that have a contractor that sit in on a mid-construction document meeting and go, you're not going to be able to build that this way. That helps so much save costs down the end, like down the line. So
awesome.
Yeah.
So is that a challenge? Is that part of the builders, the contractor scope? Has the project already been bid and won at that point where the contractors are at the table giving this feedback?
No.
Yeah.
It's an integrated design process.
Okay.
Almost 100% of the time. We have
All right.
a couple of projects market rate that are not, and they're kind of nightmares.
All right.
Yeah.
Okay. So the contractor has to be part of the team from day one.
Yeah.
Cool. Good note. Okay, one more question. One more revisited question that has a different answer, or at least slightly different answer. Dylan.
Rob.
Are there conflicts with codes or other programs with Passive House?
Oh. So, conflicts, yes, still exist, I would say. One area that we always, I think, repeatedly run into conversations about, and this is maybe even not necessarily code per se, but it's ventilation rates. And we do find ourselves on a very frequent basis having to talk to mechanical engineers about sort of avoiding the potential to overventilate spaces and thus increase the energy use in the building that would exceed our energy cap for Passive House. So we have an energy model. We have to model the ventilation rates as they're designed and as they're intended to operate. If there's any sort of scheduling to those ventilation rates that we need to factor in, we'll account for that. And a lot of times we find on a regular basis that the basis of design from the mechanical engineer's perspective results in an air change rate in our building, an amount of air that's exchanged in and out of the building that's just much higher than what's really allowable to achieve the Passive House energy use targets. And our model shows that.
So the standard ventilation designs are just way too much airflow. Is that okay?
Right.
No, not the infiltration rates. The
correct.
ventilation.
The mechanical ventilation.
Yeah.
So that's one area where we've found some conflict and just having to really hone in with mechanical engineers on what really is the code minimum level in these requirement or in these space types. If we can accommodate a little more ventilation here or there, we'll try to make that work. But at the end of the day, we have to meet these energy performance targets, and this is one area that we are constantly in a battle with.
So Lois, have what codes or standards have changed? Like the Passive House standards, I don't think have changed as far as the ventilation required, the minimum ventilation rates. Have other codes and standards?
Yes. The new IMC, the last couple cycles have increased the ventilation rates, the exhaust ventilation rates in the kitchens and baths. And because Passive House has to balance the ventilation in the building, so does the supply.
Yep.
So we're now operating at almost double the ventilation rates if we build to the IMC. The latest IMCs.
Double the minimum rates that Passive House requires.
Exactly.
Okay.
So that's really difficult. It requires doubling the ERVs, and if you're using a central ERV, that's a lot of roof space. And if you have a narrow, small building, it's tough to fit those ERVs on the roof. So there's a lot of conflicts with it. There's also been conflicts with things like fire-rated windows and fire-rated doors that meet the levels of efficiency that we need for Passive House, which have to go in certain circumstances. And we still don't have Passive House levels of those. I'm not sure we ever will, honestly. I don't know how you would build a fire-rated window frame that was Passive House levels of efficiency, right? Like, I just don't think you can do it. But it's all doable. Like we said, it's design-based. But I do know when we started with our first big projects in 12 years ago, we had a list of code and program conflicts that was a whole length of a page in tiny font, on a slide.
Okay.
The next one we did, it was about cut in half a few years later, and now we're down to about a quarter of the conflicts that we have.
All right.
So things are getting easier, more products are available, thermal brakes are available, all this type of stuff, but there's still some conflicts with some codes.
Gotcha.
And so we, got to work around
And ventilation is a biggie.
it. That's a big one. It's
a big one. Yep.
Okay.
Yeah.
Cool.
On the flip side, like I said earlier, alluded to earlier, Massachusetts has essentially required passive house for code in multifamily buildings in Massachusetts. So, the evolution of codes has just been really exciting to see and interesting.
I mean, it'll get tricky if you require passive house and then require ventilation per the IMC.
Oh, yeah. This is a very active discussion. Okay.
It's a hot topic right now.
Yeah.
All right.
There's
As
code
it was-
considerations submitted. There's,
Oh, yeah.
Okay.
there's national labs involved.
Yeah, it sounds like this issue maybe has some different angles to it than 6
Yeah.
years ago, but it's still one of
still
the
an
hottest
issue.
topics. Yeah.
Yeah. I always say the banes of my existence in the passive house world are ventilation and windows. There's always something that comes up.
Which were the two big cost pieces that Lois mentioned
Right,
in the
yeah.
first question. Yeah.
Yeah. So there's so much complexity to it. There's so much, I'd say, confusion in the industry around it. So, we try to help alleviate that confusion and make things clear where possible. But it's always a discussion: is what's going on with windows, what's going on with ventilation.
Yep. I'm not going to. We'll move on because if I don't, we'll spiral down into a rabbit hole, which we'll never get out of.
I'll
You're a
need
good
that
host.
cocktail.
All right. So, new questions. Questions that you're getting a lot that you didn't get 5 or 6 years ago, or at least not so much. Number one on the list: does passive house only address energy? Lois.
It addresses energy, comfort, durability, and indoor air quality. The indoor air quality focus is the ventilation, fresh filtered air supplied to all living spaces and exhausted from the wet rooms. Highly filtered, so MERV 13 filters on the supply. So, and the attention to the thermal bridging in the envelope, the reduction of the thermal bridging through the envelope, ensures that you're not going to have condensation problems inside the cavity of the building that could cause corrosion and mold, or on the interior surfaces, which we've seen in so many apartment buildings because of those, especially those roof wall connections, the slab edge connections, where everything gets really cold in winter and mold will grow and condensation will form. So that's the durability piece and the health, and part of the health piece. That envelope thing is durability and health together, right? The comfort is no surface on the inside should be cooler than 7 degrees lower than the indoor air quality, the indoor air temperature. So if my thermostat is set to 68 degrees, no surface should be colder than 61 degrees to ensure thermal comfort.
Ah,
So
okay.
it's built on a thermal comfort standard as
Gotcha.
well. So and then energy efficiency, right? It's like just crush that heating and cooling demand. So,
Yeah.
Yeah.
Yeah, it's interesting. So I'm a little bit out of the program world these days, but we're involved. Our company, our group is involved in a lot of programs. And I think if you asked anybody in our group who works on LEED and Energy Star and IAP and Enterprise, yada, yada, all these things, their answer would be, passive house is all about energy.
Uh-huh.
And it's certainly one of the most rigorous energy standards, but all those other programs which have been accused of being fluffier on the energy front anyways, but it addresses things like materials, finishes and paints and off-gassing and VOCs, starting to more and more to address embodied carbon for bigger climate pictures. Thoughts on that? I know we have a lot of projects that do they do LEED and passive house. And so there's lots of different programs.
Well, like I said, it was initially based on a comfort standard with the idea that ventilation was one of the most important things in that highly energy efficient home. So the people who think it's all about energy just don't know the background of it. And I don't know how you could say that if when you put a passive house project through LEED, it gets most of the energy points, it gets a ton of the indoor air quality points, and I think
All
there's
right.
some comfort points in there too that you can get. So like how you can say it's just one or the other, I don't really know. And I'm not joking when I tell you, the Germans just assume you're not going to put bad shit in your house.
All right.
So why would you put something with formaldehyde in your house? Like it doesn't even occur to them over
right.
there, you know?
Okay.
So you gotta.
The baseline,
The baseline is
there is
different.
different. Yeah. That's
Like, of
it's an
course
interesting
you
question.
wouldn't put that in.
So there's an obvious potential disconnect
Yes.
between ventilation being the key factor in the IEQ, and the ventilation rates being half what other codes are starting to require here. But I think the answer, and correct me if I'm wrong, is the filtered, balanced, fresh air is-
Commissioned.
Verified rates.
Yeah. With some of the buildings we've been monitoring longer term meaning 6 months after occupancy, maybe we're not seeing the performance we want to see. And I mean, Dylan, I'll ask you. I mean, you've been involved in the monitoring projects, and we don't have to get into the details, but
Sure.
The ventilations, and we talked about it with O&M. The ventilation systems are a big challenge to get operating properly.
Absolutely.
And I mean, is there a disconnect in your mind between ventilating less than other codes require, but making up for that with the filtered balanced, mandating the filtered balanced, commissioned in air quotes, ventilation?
Yeah, I mean, I think there is a disconnect in types of ventilation. Exhaust only or supply only versus balanced is a big difference. So, if you're thinking about an exhaust only or supply only type system, you're creating things like pressure differentials throughout the building, throughout apartments and whatnot that could cause air to come in from neighboring apartments. That doesn't happen with a balanced ventilation system. So, most apartments that we see today are non-smoking, but that doesn't mean people aren't doing nefarious things in their apartments, right? And COVID is also, was a big aspect of the last few years. So there is something to be said about types of ventilation in addition to rates. So I think the two have to be looked at together in a package, as opposed to just wrestling over how many CFM is good and how many CFM is bad. I think it needs to be how much CFM with this strategy is good versus how much CFM with that strategy.
And the issues we're seeing are more with moving parts on the ERVs, right? The wheels in particular, is that correct?
Sensors, controls, integration between controls and coils. And
what we would like to see is maybe more fixed equipment, maybe more fixed plate stuff that you don't have to worry about that.
That's a good point.
It's a lesser efficient piece of equipment, but it can still be very good.
Okay.
And much less maintenance.
Huh.
And I think if we just, let's level it. Let's say all ventilation systems are operating as they were designed. Let's say that. in a
if we're in a fantasy world, sure.
Let's say that. So I have a system in a balanced passive house that's working. I'm getting my 45 CFM fresh air. It's 45's leaving. It's going through my ERV core, whatever. And then I've got an exhaust-only building with 45 CFM being exhausted from that building. And I have one exterior wall. And 45 CFM of fresh air is not coming through one exterior wall, even if you only build to lead. At 0.4 CFM at code, you are going to get about 6 natural.
CFM?
Yes.
Yeah.
It's it.
No.
Right.
You know?
That's a good point.
No,
So-
I mean, with the air tightness of passive houses, exhaust-only ventilation is absolutely
But in
impossible.
in anything, you're only going to pull it, in any multifamily, you're only going to pull it from neighboring buildings or the hallway, unless you open a window. In an exhaust-only strategy, I can do it. The math is so simple.
I agree. But, well,
And we're assuming the systems are all working the way they were designed.
put a pin in that. There's no easy, in my mind, there's no easy answer. There's just no
I think
easy
we're going
answer.
back to trickle vents, Rob.
I know we did tests on those, and we found that
know.
those don't
Those
work.
don't work
Those
either.
don't work reliably either.
Well, you can, and real quick too, you can open a window in a passive house.
Yeah.
Because that was one thing we talked about on the first episode, 5+ years
and that
ago.
question we struck that from the FAQ
Right.
Yes.
because you're just not getting that anymore.
Not
I guess
We're
not-
So
right,
that's-
exactly.
Yeah.
Not
Okay.
no.
So that's good. That's
Yeah.
it's people are coming.
It did come up in an interview the other day, though.
Did it really? Opening windows. All right. Good. So you can't open in Windows. You must be able to open. Is that right? You must.
You actually have to.
You have to.
Okay.
If you are going to put in fixed windows, you have to justify it.
Okay. Okay.
And even that's, I don't think allowed even in residential.
Office.
Right? It's really just for office type
Okay.
projects. Yeah.
Gotcha.
Yeah.
Gotcha. Okay. Cool.
Okay.
All right. Moving on. Dylan, you touched on this. What are the actual operating costs and savings?
Yeah. So, one thing that's great now as opposed to 5+ years ago is that we have, I don't know, maybe 2 handfuls of operational projects that have been in operation for at least over a year, some a few years, and we have energy use data. And one of the things that's exciting is that we're able to look at something like an EUI, which is a common metric for looking at energy use. It stands for energy use intensity, and that's essentially the total amount of energy used by the building on a per square foot basis. So per square foot of the entire building's basically square footage. One thing that we're finding is that our passive house, particularly multifamily buildings, which is the ones that we've had in operation for long enough to do this type of analysis, are kind of finding a home somewhere in the mid to low 30s in terms of a site UI when you look at this on a KBTU per gross square foot per year basis. And when you compare that to conventional buildings, benchmarks, comps, that sort of stuff, the good thing about New York City, as an example, and Boston is they have public data on energy use in buildings over a certain square footage. So we're able to look at things like benchmarks. And what we're seeing that these benchmarks are in the 70 to 80 range. Now, some of the newer buildings might be in the 60 to 50, some in the 50s, but most 60, 70, 80. So we're talking about measured site energy use intensity in the 30s for these buildings. Is where sort of the average is coming in at on a lot of these buildings, or most of these buildings.
Half, so
And
at least half.
that's about half of what the conventional benchmark is. And if you were to tell me that 5 years ago, if we would be using half the amount of energy in these buildings than conventional buildings, I would be sign me up for that any day, because that's a big accomplishment. So certainly still some things to be addressed, but we're seeing data come in that suggests that it's using about half.
And a caveat there, those are all electric buildings except for the domestic hot
I was
water.
just going to ask that.
So
Right.
those are gas in all of the buildings that we have data for so far.
Gas, water,
Our
heating.
next generation will be electric. So if you look at the gas and you were to assume that energy usage from a heat pump, you would cut that in half. It would bring you down into the upper 20s to lower 30s for site EUIs, which is really impressive. Really impressive.
Yep. Cool. Yeah, that was one question. Is the gas, water heating so far, but we're moving. Yeah, a lot of projects moving away from that towards heat pumps or even resistance. The other question I had was, so those EUIs compared to modeled EUIs.
Right.
I've heard you
question.
grumble about that quite a bit, Dylan.
I think on other podcast episodes I have.
So that those low to mid 30s, how does that compare to what's modeled?
So, compared to what's modeled, there are, in our energy models, there are standard assumptions that are required to be standardized for the purposes of, maintaining consistency across buildings, particularly with unregulated loads like hot water usage, temperature set points, electrical energy consumption in apartments. Plug loads is kind of the name for that we'll use a lot. And what we're finding that those, in our opinion, are a lot lower than reality. And what we're finding is now through some actual analysis of data and attempt to look at, well, how does the model compare to actual usage for things like hot water consumption? They're just low, and we're finding that
the models are low.
The models are low,
Okay.
right? So, with a typical passive house model for a multifamily building these days, if you look at a site UI for those buildings, the calculated site UI is more in the high teens to low 20s right now.
Okay.
So, and we it's not necessarily a surprise, and it's consistent because of the fact that we are, pretty darn sure that it's related to the fact that the hot water consumption is just really, really low in terms of gallons of hot water consumed per person per day. Temperature set points are optimistic in the models. So
for heating,
for
and cooling?
space heating and space cooling, exactly. There's still some more work to be done, I think, in terms of looking at other internal loads like apartment plug loads, but we are actively trying to look at those loads and look at actual monitor data to see how does it compare to the models. But yeah, hot water consumption, temperature set points, and then especially for the bigger buildings, there's just a much more of an unknown factor with things like elevators and pumps. So like a fire pump, which might only come on once a month, does that use a crap ton of energy when it is used for the couple hours it might be on, or however long that might be on? So I think bigger buildings offer another layer of load that is harder to kind of hone in on where the models might be off. We're making attempts to make our models more accurate, but yeah, they're still off.
So, correct me if I oversimplify. Passive houses, actual energy consumption, the actual EUI is about half what conventional new construction is.
Yep.
For passive houses. The modeled EUI is about half of what the actual EUI is for passive houses. Maybe not quite half, but 40% lower.
Not quite half. If you just double the domestic hot water usage, so we assume 6.6 gallons of hot water per person per day.
6.6 gallons per person per day.
What we think is it's closer to between 13 and 15. So if you just double that 6.6 and get yourself to 13, you actually come to within 10 to 15% of the totals.
That's a lot of hot water.
It's a lot of hot water. But we think it's even higher based on comps that we've been getting from New York City's data from multifamily buildings.
Oh.
We have thousands and thousands of buildings in the database that we've been downloading and analyzing, and it's quite impressive. You can isolate the EUI for the hot water based on the profiles, and it's only supporting what we know and possibly even suggesting that we should be assuming more.
Okay, so we got a summary of EUI. Costs, though, Lois. Operating costs are not EUI. How do operating costs differ or vary, or how do they come in?
So I only have the evaluation of one developer's buildings, two separate buildings. One that was built to code was gas heat, gas hot water, and gas stoves.
Okay.
And the passive house one he built within 2 years of each other, which was everything electric except for the domestic hot water. Okay. So the site EUI for the passive house one was 50% of the gas building, of the code building.
Okay. Like Dylan described.
Yep. Very impressive difference. The cost savings was only about 20% compared. He was seeing savings, which a lot of people are like, we're not going to see any savings, we're going to be paying more. So going to passive house does take you that far, but it's not going to be 50% cost savings. What he will see is no local on 97 fines.
Okay.
All right. So if you're in a place that's going to have carbon fines, this is a good way to ensure that you're not going to get hit.
Like New York City and
exactly.
Lots more and more places.
Boston
too.
Yep.
Yeah.
Okay.
Yeah.
Cool. Good point. One of the new questions you're getting a lot: do products need to be Passive House certified? Dylan.
Short answer is no, they do not. That's it.
Okay, next question.
A lot of people think they do. They don't.
But there are product certifications.
Yes.
And basically is that like the baseline? Like the model assumes you have this level of performance, and if you don't, then you need to make it up somewhere else, or?
No, what happens is, let's take the efficiency of, say, the ERV. They have all these passive house certified ERVs. You can't get a lot of them in the United States, but they have these thresholds, these certified products. If you use one of those products in the range of flow that they have certified,
Okay.
you can just take the numbers from the certificate and use them straight as they are. The efficiencies, the watts per CFM, things like that.
Okay,
If
okay.
they're not, you need to supply them with some either AHRI data or HVI data, do another calculation, and usually the efficiency comes down a little bit from the rated efficiency. They do
I
a
see.
slightly different calculation.
Yeah.
So it'll come down maybe 3 to 5 percentage points, but it's usually more on the 3 side. So it doesn't kill you.
Okay.
Yeah.
And that's just ventilation. I mean,
That's just ventilation.
Windows, other things. There are, again, certifications, but you don't need to use.
It doesn't
Yeah.
need to have the stamp
And one new update.
from PHI or from FIAS. It doesn't need to have a stamp
Okay.
from them.
Okay.
Yeah.
Gotcha.
One update that I think a really positive update was particularly with FIAS's program. So not to get too into the weeds, there's 2 standards, PHI and FIAS. There's plenty of resources we can provide on the differences between the two. But in FIAS's program, within the last year, they've actually allowed for projects to use NFRC data for Windows without requiring what previously was required, which was what's called ENISO, or a European standard, and how that data is calculated. That actually is a huge thing because North American window manufacturers know NFRC ratings. That's what they live and die by. Is
Oh, they've been doing it for
rating.
decades. Yeah.
Yeah, exactly. And it was extremely encouraging, and I think a huge positive step to essentially give projects a path to use NFRC data without requiring that European standard of the data, in terms of, to our earlier point, more market availability of passive house windows. This is one big step in that equation.
Cool. Yeah, that's helpful, man.
Yeah.
Greasing the wheels.
Yeah.
Fewer
Exactly.
conflicts, fewer roadblocks, as we talked about
Right.
a few questions ago. Yeah, cool. Sweet. Okay, last question on your new list. Why does ventilation have to be separate from space conditioning? Dylan.
So ventilation has to be separate from space conditioning because in a passive house building, when the loads are so low, the space conditioning hopefully is not running for a substantial portion of the year. So if you're relying on your space conditioning system to distribute the ventilation air around the apartment or around the building, around the home, then there are significant times in the year when the heating and cooling system is not running and not distributing that air where you want it. So, it's essentially a requirement for projects. There's certain situations where there's been some exemptions, but essentially a requirement that ventilation air has to be delivered to bedrooms and living rooms. This is the supply air, and then that exhaust air comes typically from kitchens and bathrooms. But if you're relying on a strategy where you're essentially dumping the ventilation air into a heating and cooling unit, you're relying on that heating and cooling unit to both distribute the air evenly to where you want it, which is not always guaranteed depending on how the duct's designed. But also, probably more significantly, you're relying on the heating and cooling system to actually run to distribute the air. And without it running, you're not going to get the ventilation air to things like bedrooms and living rooms where you really need it, especially overnight in bedrooms.
So there are controls where you can operate those blowers and the air handlers or
Right.
fan coils continuously or on a program schedule for ventilation. Is this a programmatic ban or kind of a practical?
It's, I would say, a programmatic ban in just about most situations, particularly with FIAS. It's a programmatic requirement that ventilation air has to be delivered to bedrooms.
But it's not a programmatic requirement that it has to be separate. If you control your air handler to run 24/7, which used to be horrible because the energy penalty used to be horrible. But now that they use 35 watts maybe, if they're running in low speed, it's a programmatic requirement that air be delivered continuously. And it's just a practical, there are practical roadblocks for tying it into the heating and cooling system, or it's actually a stipulation in the PHI or FIAS standards? Maybe I'm not asking.
No,
this.
it's okay. It's practical in the sense that for us to balance the system with a tab contractor, we need to be able to measure the flows at each of those registers. And if we're running the air through ducts that are sized for heating and cooling, we don't know for sure how much actual outdoor air is actually getting to those rooms, because it's most likely at a higher flow rate than the ventilation will flow, right? Because if I'm heating with my ductwork, I'm sending a lot more than 15 CFM to my bedroom.
Yes.
Okay, so it's much larger. So for us
We'll say 50.
Okay. So it's a practical requirement that we won't be able to measure it.
But if there were 50 CFM, if the fan was on and there were 50 CFM being delivered, and you could measure a total outdoor air CFM coming into the return of the air handler of 60 CFM or whatever was appropriate for the apartment, could you assume that, if it's a 1-ton system, there's 400 CFM, which you can measure. So 60 CFM of that 400 CFM is outdoor air. Could you take that fraction of air that's delivered to the bedroom?
There's no good way to measure it, and we need to measure
There's
it.
no good way.
Okay. All right.
So a programmatic requirement is we have to have measurements to verify that they were meeting the flow rates as designed. And if we don't have a good way to stick a flow hood up or measure flow rates to each register, we don't know that the outdoor air is getting to the bedroom. We might know that it's 100 CFM of flow, but is that 5 CFM of the outdoor air, or is that 20 CFM of the outdoor air that's dumped into the heating cooling? We don't have a way to verify it. So that's one of the biggest programmatic challenges.
The one system that our contractors want to use when they do that type of a thing, it's essential ERV or large scale ERV.
Okay.
That's just dumping air
Into
to the return.
Yeah.
And so can you honestly tell me that 15 CFM of that is getting to a bedroom?
Yes. We'll have to discuss this.
Okay.
If
We'll put a bit in that.
Yeah.
Like you
Yeah.
can measure you can take a pitot tube or a hot wire or something. You can measure the flow in that duct going to the return plenum when the fan is, when the air handler is operating.
So then the other issue, Rob, not to get off, because we can go into this with the pitot tubes, is so I've got my ERV running, and then on top of that, I've got my air handler running 24/7.
Yes.
There's an energy penalty.
There's an extra energy. Absolutely.
So that's
Yep.
another reason why.
And that's
we
a
stay away
reason
from it.
why I always used to avoid it like the plague
Yeah.
until the power consumption of these air handlers got so low, 30 to 40 CFM and getting even lower. I mean, I'm sorry, 30 to 40 watts. Yes, running continuously, that's something, but
Is it like
Interesting.
another light bulb on? Like I'm just trying to think of
Yep.
equating it to how many LED bulbs. It's an interesting, I guess, math analysis.
all right. Well, practically it is a challenge too, certainly, and
Yeah.
it's a prohibitively challenging to get balanced ventilation, verified ventilation combined with a heating and cooling system.
Yes.
And it would take a lot of work. On paper, I certainly think it could be done, but I've not been through and tested dozens or hundreds of units to see if they're all balanced and working properly.
Right, and there's different ways to do it. Like we had a company try. We were the certifier for them. They tried to do this up in Vancouver, where they had a central ERV that was going to provide supplemental cooling to the apartments. This is Vancouver, so
An
they had heating in the
ERV.
apartments.
Okay.
Right, the ERV had cooling in it, and
I
so it was
see.
supposed to. And it also had these dampers on each exhaust and supply into the apartment that was supposed to ramp up and ramp down depending on the cooling need.
Oh,
Did not work.
yeah. Yeah.
Right.
Did not work.
Yeah. We keep coming back to ventilation being a challenge. We've hit
Again,
on it 5
bane
times
of
in this
my
discussion, I
existence.
think.
Open your
It's-
windows.
Oh, man. Yeah, open your windows. It's mandatory that
Yeah.
you can
Yeah,
open your windows. Okay, excellent. All right, that is the last question. But very briefly, one question, which I think I asked you, Lois, when we wrapped up our last conversation. What among our clients, what types of buildings is it? You mentioned affordable housing a few times. Who's building passive house and why? And Dylan mentioned that it's required in Massachusetts for a lot of multifamily or affordable housing. What's the biggest segment of the construction industry that's going towards passive house?
So besides multifamily is going to be the dominant one. It's dormitories.
Okay. And affordable housing is
the majority for now, but Massachusetts is going to change that.
Okay. So in Massachusetts, Dylan, it's not just affordable housing; it's multifamily. That's where
it's
passive
required for multifamily, but it's a code compliance pathway for any building type. So we're having non-residential buildings. We have a medical imaging facility that's fairly large scale. That's one of the more complicated projects I think we've worked on, where there's a core and shell design, there's a tenant fit out, there's all sorts of things that would make this whole process harder, and they've committed to passive house because it's their code compliance pathway.
Wow.
Yeah.
That sounds like a lot of juice in a medical imaging facility.
Office space.
Yeah,
office. The first project I've ever worked on was a clothes manufacturing facility in Sri Lanka. You can do, and that project is using substantially 60% less energy than when it was using before the renovation. So, it works. If applied appropriately and looked at, in the right way, it really does work for any building type.
Excellent. Thanks both.
Thank you. Thank you for listening to Buildings and Beyond. Before wrapping up here, I'd like to try and add a little more clarity to our discussion on ducting ventilation air into heating and cooling units as a means of delivering fresh air to terminal registers. While this approach is not prohibited outright by PHI or FIAS, there are very real challenges with getting this right regarding balancing, verifying design flow rates are being met, and ensuring passive house energy budgets for a project are not being exceeded. Buildings and Beyond is produced by Stephen Winter Associates. We make buildings better. Show notes with helpful web links relative to the topic of passive house can be found on our website, swinter.com. Special thanks to our guest Lois, our host Rob, and our podcast team, Trisha Carr, Heather Breslin, and Ian Slackus. Cheers.